I'm talking to you. This is Goddess of Science Physics, and I'm Mrs. Bolton, and today we're going to talk about media that transmit sound in part 3 of my sound series. Okay, so let's get right to it. Let's reveal the big secret here. Sound travels in solids, liquids, and gases. Well, would you look at that? It's pretty much everything. So, sound is conducted in solids, liquids, and gases. If you just wrote that down, you don't have to write it down again, obviously. You probably have some practical experience with gases like air. I don't know, you hear on a daily basis. But you can also transmit sound through liquids. If you've ever been swimming in a lake or a pool and somebody clacks together two rocks underneath the water and you happen to be underneath the water, you can hear that. It usually sounds very loud and very clear. Also, it can be transmitted with solids as well, and we'll talk about that in a little bit. So, sound is transmitted louder and faster by solids and liquids than by gases because solids and liquids have their particles much, much closer together than gases do. So it's easy for the vibration of one particle to vibrate the next particle because it's right nearby in liquids and even closer in solids. So that's why they transmit very, very fast because the media, the particles of the media are so incredibly close together in solids and in liquids as well. And here's the example that I used before. You can hear the clicking sound of two rocks banging together if your ear is underwater, and the rocks are underwater as well. So the speed of sound is different depending upon the materials that the media that you're hearing it through. And back when we talked about the speed of sound and how it doesn't matter what the pitch is, the sound is going to be the same as long as it's being heard through the air. But if you're listening to a sound that's heard through water, it's going to be different. The speed is going to be different. It's going to be different if it was heard through a solid as well. So sound is faster in liquids than in gases and even faster in solids. So if you want to do like a little shorthand way to say this, you have gases and then liquids are the speed of sound is greater than liquids than in gases, and the greatest of all is solids. Sound travels faster through solids than through liquids than through gases. So solids are kind of interesting. You probably, maybe you have, maybe you haven't, seen old Western movies where they want to find out if the train is coming, so they or they want to find out if there's some cavalry coming or soldiers coming on horseback. They put their ear to the ground, and that actually works because the sound that is made by the horses clomping on the ground or the train that is far off moving along the tracks, that will actually travel faster through solids like the ground with the horses than it would through the air. So you'll hear it a lot quicker if you put your ear to the ground, which is solid, than you would if you just listen for it in the air. Sound can't travel in a vacuum. Here's the kind of a weird thing. Sound has to have something to move through. It has to have little particles that can vibrate. But in a vacuum, we're not talking Hoover here. We're not talking, the Dyson. We're talking a space without any air in it. Well, sound can't travel in a vacuum because there's nothing to vibrate there. The transmission of a sound requires a medium. There can be vibrations, but if there's nothing to compress or expand, there's not going to be any sound. Sound can be heard from a ringing bell when it's inside something called a bell jar. This is kind of a classic experiment. You put an alarm clock or something inside there and you make it go off. But because you've sucked all the air out of this little jar, you can't actually hear the sound of the alarm clock or the bell going off because there's nothing to vibrate in there. You might be able to hear a little tiny bit of it because unless it's suspended in here, it's gonna vibrate whatever it's sitting on, so that may have a way, but it's not gonna be loud. It's gonna be, very, very faint, if anything is all at all. Well, that's it for this time. Thanks for joining me. Have a great day.